Good morning, everybody. Good morning, sir. So, am I audible to you?
Yes, clearly. Good morning.
So, we will start our session in 3 minutes.
Okay, sure.
Okay, good morning, everybody. So, we will start our session 1 of the day 6 Ethereum network. Over to you, sir.
Thank you. Can you give me screen share?
Sir, it is allowed.
Thank you. So good morning, everyone. Thank you all for joining. This is going to be the last session for this course. And for today, our objective is to learn about Hyperledger and also take a look at the small issue that we ran into yesterday with our Ethereum client. And as stated earlier, feel free to make it interactive. Feel free to interrupt me and discuss anything that is either related to the topic or something that we might have discussed in the past. Having said that, I don't have any slides today. We will purely conduct this as hands-on. And before we start with our Hyperledger discussion, just wanted to complete what we were trying yesterday, which is to create a client for our blockchain smart contract on Ethereum. So I'm sharing the code that we were trying to run yesterday, which was an HTML page. Inside this HTML page, we have to import web3.js, which is the library that allows us to interact with a smart contract through all of the capabilities that it has. So there's not a lot in terms of what we are doing in the body of the page, but there is a script that basically does the connectivity and the transaction initiation bit of it. So we did a quick walkthrough of this code yesterday as well. We looked at how Web3 needs to be created with either a MetaMask integration, which is through retrieving the injected provider, or through a node connectivity. We will be using the injected provider. And then we have to define the contract address that is the place at which we've deployed our contract. And we have to define the ABI or application binary interface for that contract. So once we have these three things, the Web3 handle, contract address, and ABI, we are in a good place to call our contracts. So the way to do that is first thing we'll do is get the number we stored. So yesterday we wrote that very simple storage contract. Let's just take a quick look at it. This was our storage contract in which we stored a number and then we retrieve the value of that number. Every time we write a contract, we are basically doing something very similar, which is either updating a value or retrieving that value. Now that value could be very complicated struct, or it could be a simple number as it is right here. And the ability to retrieve the value and the ability to update the value is all something that Solidity provides through its assignment logic and creation of mappings, structs, and loops and arrays that we saw yesterday. So we'll quickly run through this, and then we have to get to Hyperledger. So the first function I'm calling is getNumber, which will give me the actual number that I stored. I was running this last night. So the problem we were running into yesterday was related to the wallet configuration in the Brave browser. So what I did was I downloaded Chrome and installed MetaMask inside Chrome, and it was working without any issues. So I'll just have to sort out the wallet in my Brave instance. So taking a look at this code again, the contract instance is created via this code. You call web3eth, and then you instantiate the contract passing in the ABI and the contract address. Once this contract is created, there is a methods object inside the contract using which we can call the actual Solidity methods. So retrieve is one method, outwhere store is the other method. And then for initiating a transaction, you'll have to call send, passing in the from account, the gas price and the gas fees, maximum gas fees that you're willing to pay. And for calling a view function or just reading state of the contract or the blockchain, you just have to call the dot call, passing in just the account, because you're not going to be paying any fees. And we talked about this yesterday as well. So the first thing I have to do is, let me see if I'm already running it. So the first thing I have to do is inside this browser, inside the location where I have this HTML file created, I need a way to access it through an HTTP server. So the easiest is I use a Python server. Just open it and you can execute the server like this. It makes this directory available over 800 port. And what I just need to do is access, let me just relaunch everything. I need to just access the 800 port. And this page is accessible as a website. Now I've not done anything on the UI. All I'm doing is console-based testing. Make sure that you're logged into your wallet. So we're connecting to the Kovan network. I have decent amount of money to test my code. So the very first function we're calling is getNumber, which prints the number on the console. So the number that I had stored earlier was 20. And that is what it is printing out here. Now I can store any other number, let's say a big number, and I can call the add number function. The moment I refresh it, it's going to launch MetaMask because that's the integration I have. It will prompt me to send a transaction. I can see the transaction on Etherscan. So you can see this transaction, it came 12 seconds ago. This transaction was for the store call. So you can see that I'm calling store. This parameter is encoded, hex encoded. So this is the value of the parameter. Now all I need to do is ensure that my value is stored. And I can do that by going back to this code and calling back get number again. Just need to refresh this page and I see the number that I stored. So that's the client part, which calls smart contracts on the blockchain. And we just tested it on testnet. Now I'll jump to Hyperledger and I'll refer to the document that I shared with all of you yesterday. But before that, any questions, thoughts, comments on the Ethereum part of it? All right. So a quick refresher of what we talked about earlier in Hyperledger. One, Hyperledger is a private blockchain, which means we'll have to deploy it and run it. We don't have a test net to use. Second, Hyperledger has a lot of different modules that have to be separately executed. Thankfully, Hyperledger provides scripts for us to execute them for creating a typical business network. But underlying those scripts are commands that you would need for any kind of network setup. Number three, Hyperledger works in Docker. Docker is a container environment. The smart contracts, that is chain code, the Hyperledger fabric components like orderer, peer, certifying authority, all of them get executed as Docker images. Number four, with Hyperledger, since most of the time what we do is building smart contracts in Ethereum, we did not need to do a lot of network setup and a lot of permission setup and all of that in Hyperledger, although all those facilities are there, but it is completely fine to decouple or to not worry about how the network setup is happening. There are links here that tell you how your deployment needs to be done and what are the considerations for that deployment, which is this one. And the reason why sometimes developers don't really go in depth into the deployment consideration for Hyperledger is that it is very complicated. There are multiple things that have to work together, like you have to set up a certifying authority server. You have to set up a node that runs two kinds of peers. One is a committer peer and the other is an orderer peer. And then you have to worry about the database because Hyperledger provides options which kind of database you want to work with. Out of the box, you get CouchDB and LevelDB. So there are a lot of decisions that need to be made, like step 1, decide on your network configuration. Step 2, set up a cluster of your resources, which means you will have to set up a group of servers. Obviously, for our test, we will be just running it on this system. And then you have to create certifying authorities, cryptographic material. Now, Hyperledger uses RSA, asymmetric cryptography, or public key infrastructure for creating digital certificates, verifying digital signatures, managing identities of entities that are on the network, all of that. So there are two kinds of certificates. One is the certificate using which you can verify a digital signature. Number two, certificates that manage the transport layer security, or TLS. So all of those are managed by Hyperledger using the certifying authority server, which is Fabric CA. So you'll have to kind of get in depth and ensure that you understand how all of that operates. And then you'll have to decide on which Fabric CA component you use. One comes out of the box with Hyperledger. It's called Fabric CA server and client. You can also use some external ones. So that is a decision that you have to make. So a bunch of decisions, and then you can actually do the deployment. The good thing is that you can still work with Hyperledger, just focusing on your chain code, smart contract, and its clients, using what is provided out of the box by Hyperledger. So Hyperledger has a set of demonstration samples for 6 or 7 very typical use cases, and you can use them directly in your project by making some small customizations. And this document that I had shared yesterday, it talks about all of that. What I would request you to do is, if you have a project on Hyperledger and you want to build up a demonstration for that project, go through the document. It's not very long. It's, I think, how many pages? 16 pages. So, I mean, reasonably long. You can take a look at one use case analysis for a demonstration code that's provided by Hyperledger. It's called FabCar. And if you understand that it is perfectly fine to just change some parts of FabCar, like its name and some flow and the backend chain code, to use it in your project directly. So having said that, let's start our own demonstration. What I have done for Hyperledger is, let me get rid of these. So what I've done for Hyperledger is I've created a directory, an empty directory. It has one subdirectory inside it, which is, I mean, which I've created day before yesterday, trying to set up everything. But the steps that you have to follow is, first create an empty directory. And even before that, it would be good if you do all of this on a Linux machine. Hyperledger works on Windows. It also works on Mac, but it is much better suited to and is more compatible with Linux. So start with an empty directory, and then you can use this document as your starting point. First thing you have to do is you have to install some prerequisites. So the list of prerequisites are available in this first link. There are 4 prerequisites that you need. First one is Git. Most of the developers have it. Git is a source code management system. In Hyperledger, it is used for script commands that pull code from repositories. Then you need CURL. Again, Linux has it by default, but if you don't, there is a link that tells you how to install it. There are some extra steps for Windows that are available here as link. Those are the two tools that you need. And then you need Docker and Docker Compose. These are the four dependencies that you have. For Docker, there is a link here that tells you how to install it on Windows, Linux, or Mac OS X. You can go to that link. It's got all the steps that you need for the installation. You can go here, or you can Google for your specific platform also. Docker is a very popular tool, and you'll find different set of steps and different websites or cloud service providers that tell you how to install Docker. The version of Docker that we are looking for is, so I already have Docker installed. So the version that you are looking for is anything beyond version 17. I have the latest version 20, but I think 17 works fine with the current Hyperledger install. Once you have Docker, you can test Docker by running the, I think there is a hello world image that you can download and run. It will say something like this, unable to find image, and then it will download it. And you should see something like this, hello from Docker, and these guidelines. So this is the Docker environment on this machine. Next, you need the Docker Compose. Docker Compose is a simple command that accepts a Docker configuration file and then runs it in your Docker engine environment that you installed. So again, there is a link to install Docker Compose also. You'll find it here. Actually, it's not there. A simple Google search can tell you what are the steps for your specific platform. For Linux, it's a simple script execution. This is a script. What you may also need for Linux is to, so it's just a simple executable that it downloads, which is called Docker Compose, that it copies into this directory, user local binary or user local bin. But you have to change the permissions of Docker Compose to make it executable. chmod +x, then this path. Once installed, Docker Compose can also be tested. You can just take a look at which version you have. I have 1.2, 1.29.2. I think anything beyond 1 is fine. So with this, you have everything to run a basic Hyperledger network. There is one more thing that's needed, which is a JavaScript or Golang or Java environment. So as stated earlier, Hyperledger allows you to run smart contracts in any of these 3 languages. In fact, 4 languages. It also allows TypeScript. So since we are only talking about JavaScript, we will focus on the JavaScript environment, for which we need the Node Package Manager NPM and Node.js. I have already installed it. on this system. You can test it. The version for npm I have is 6.x. The version for Node that I have is 14.9. Current version I think is 17, but 14 works fine also. Make sure you have these two installed if you want to deploy, run, and test, and build smart contracts. So basically, you've got 5 things, actually 6. You've got Git, you've got curl, Docker Compose, Docker, npm, and Node. These are the 6 prerequisites that you need for running your Hyperledger environment. So once you have all of them installed and ready, the next step is to install Hyperledger. And that step is thankfully very easy. On this same link, on the next page, you have a script. Just copy this script. It's a curl executable, and run it in your empty directory. It will do a lot of things. It will pull this fabric samples directory. It will pull all the Hyperledger images for your Docker, and it will do a couple of tool installs with right compatible versions and everything. So the good thing is that everything is there inside this script. We don't have to worry about versioning and tooling and so on and so forth. And what I've already done is I've run this script inside this directory already, and I have fabric samples created. You can also check that I have all the images for Hyperledger Fabric. So you can do a Docker image ls. What this does is it lists all the images that are there in your Docker environment. So you need these. In fact, I don't have anything else apart from Hyperledger in my Docker environment right now. It's a fresh install. But on this machine, I've tested Hyperledger numerous times. So that is why you see different versions of Hyperledger, orderer, peer, tools, and so on. Having said that, when you will run this script, it will take some amount of time. The download is around 1,000 megabytes, 1 gig. And then there is a lot of network interaction along with that. So let me get rid of this. So once you run this script, all your installation work is complete. You are in a good place to start. Now, the first thing you have to do is go inside this fabric samples directory. So this fabric samples directory is a pull of the Hyperledger GitHub repository. You can take a look at this on GitHub. It is a pull of the main branch, and you're getting all of these subdirectories inside it. Now inside this, there are, as I said, numerous use cases and scripts and sample code that helps you execute Hyperledger in different situations. Now, what you have to ensure is that you pick up one use case. I'm picking up a very simple one for the purpose of this call, but you can pick up any one of them. Commercial paper is a very complex one, and you can read about commercial paper on the Hyperledger README pages. It's mostly about the business side of it. You can just do a search for commercial paper. So there is a very detailed tutorial on how this how this entire code base operates. We'll not go into it because it takes a bit of time to establish everything and see everything working. What we will pick, as I said, is another use case which is slightly simpler. It's called FabCar or Fabric Car. Inside Fabric Car, what you'll find is there are 4 subdirectories, and each one of them has the client code that is going to interact with the FabCar smart contract. So that's the client part of it. The server part of it is chain code. And inside the chain code directory here, what you'll find is the FabCar directory, inside which there's, again, multiple languages. And inside these multiple languages, we'll pick up JavaScript. Your actual smart contract code is in here. And we'll quickly take a look at what that smart contract code is. Now, these are just the 2 directories that you actually need to worry about. Although they use some subdirectories, some other directories also, like when I run the FabCar end-to-end use case end-to-end, it will use this test network, which basically builds a network for me and then sets up organizations for that network. And once that is done, it compiles the specific chain code that is inside this JavaScript directory and then deploys it on the test network and then gives you ways in which you can call the client. So before I start running the scripts, I just want to give a high level input of what we are going to be trying to do. First is we will build a network, and how that network will be built is using some default configurations. The basic script that gets executed when we build a network is this network.sh script that's inside the test network directory. Inside the script, you'll see a lot of shell commands. And all of the analysis around these shell commands is in that directory in detail, but I'll just go over what happens at a high level. When this network script starts with a parameter up, then what it will do is it will call network up function that's implemented here. Do a quick search. Inside network up, there is a call to check prerequisites. And then there's a call to create organizations. Check prerequisites is another function. You can take a look at that. Inside this check prerequisites is just checking whether you have all the binaries installed, and there are a lot of tools that you'll run as a part of this script execution. It just checks whether you have all of them available or not. For example, peer. So it will check whether you have peer on your class path. Peer is installed inside this bin directory, this peer executable. So this script basically does all the checks and then it executes your Docker compose. So once all the checks are done, it creates organizations and then creates a consortium, which is a network. If you look at what it does in create organizations, it runs this cryptogen command, which creates cryptographic material using this configuration. All the configuration is in YAML format. So you've got crypto material for organization 1, crypto material for organization 2, crypto material for the orderer. After generating this crypto material, which is basically certificates and private keys and so on, then it runs a registration of that identity set that you use, like your wallets are created, now you want to register them for organization 1, organization 2, and then once all of that is done, parallelly it starts the Docker Compose, which brings up the network. So I'm basically running through all of this because you need to know where all of it happens, but it's a very complicated process, which, if we go back to, let's say, test network, there are, these YAML files, which are, so what we are creating in the test network is a 2-organization network where first organization name is org1, second organization name is org2, and there is an orderer that is also set up. So this YAML file that's there inside test network Docker directory, it has a configuration for all these three. You see volumes getting created for orderer, peer 0 on org1, peer 0 on org2. And the whole network is called fabric test. So the configuration for orderer is right here. This is the configuration that Docker needs: the environment, what are the commands, which image to launch. All of this is inside this configuration. Similarly for org1 and org2. And all of this environment requires that crypto material to be pre-created, which we are creating here. Once all of that is set up, then it calls create organization 1, create organization 2, and create orderer. These are scripts that are again implemented inside the scripts directory. Was there a question? No. So all of these similar YAML files with their own specific configurations, they are available in different folders inside this test network. So setting up the test network is the most complicated part of Hyperledger Fabric. And unfortunately, since it takes a long amount of time to actually go through all of that, we will only be able to see it at a high level. But what we will see is how does it deploy the contract and run the contract. So first thing I'll show you is I'm inside Fabric samples and inside the test network. What I can do is I can run this script. I'll make a small change to this script because otherwise it all runs in the background and we'll not be able to see anything. So instead of running Docker as a daemon, I'll just run it as a console output, which is what I did right there. So I run this script like this. Now you can follow what is happening on the console, and that's going to tell you a good amount of what we are intending to do here. Let me first bring the network down because I've run it a couple of times in the past, so it was already running the network. So it runs with multiple command parameters: up, down, channel, deploy chain code. and all of those are available in this script. When you scroll down to the bottom, you'll see up, create channel, deploy chain code, and down. I'm bringing it up again. Now you'll see some amount of detail here. So it's creating crypto material for org1, org2, orderer, and then it's basically generating connection profiles, which is what we will need for connecting to the Fabric network. And then it is basically creating these images that are going to be a part of your Docker images framework, where it's created this orderer image, this peer image, and running them. So it has created them and it's running them as we speak. Now, what I want to do is I'll bring this network down again. Now we want to see something happening. So we will go to our FabCar directory and do a quick walkthrough of what is happening there. Before I do that, just want to tell you that it is okay to consider this network as your base network to do anything, any testing work. So obviously when you go to production and you're dealing with real organizations and entities, then you'll have to revisit all of this in detail. Maybe I want to rename this org1 and I don't want to have 2 organizations. I want to have 7 organizations. So all of those configurations are going to be made here. You will be looking at this Docker configuration. Then for crypto material, you will be looking at this material. And inside this, you'll find that there is a lot of detail around what are the certificates, what are the users in each organization. For example, let's say for organization 1, you have 2 administrators, or maybe 1 administrator and 1 payer and 1 client. So you'll create policies like this. You'll have readers, as in the users who are allowed to read transactions. Then you'll have writers, the same users you add there, but you've not added the peer. Then you have admin, that who's allowed to be the administrator. You define the admin. What you'll basically be doing at some point is when you're going to production, this name will change. This name will become the actual name, and you will be having more granular policies, like maybe instead of or you'll have and or something like that. So all of this configuration defines that entire access control and hierarchy I was talking about earlier. It's in a format that you can replicate, and thankfully it's well documented. So if you read about this in these comments, you'll be able to understand what it's doing. It's basically setting up all the organizations and their policies. And then it defines the capabilities of those policies, like what are the channels that you'll be setting up and who has rights on what channels and all of that. And then finally, it defines the profiles. We are creating a certain profile for your organization. There are 2 profiles, 2 organization, 1 orderer Genesis block profile, which has this hierarchy, and then 2 organization channels, which has this hierarchy. So in most cases, you can keep this as default, but places where you have to change it, you will have to analyze your requirement and match it and then change it accordingly. Now let's come back to what we were trying to do. We brought the network down. Now we don't have anything running. Let's come out of this directory. Let's go to FabCar directory. Now, if you look at the FabCar directory, it's got 2 scripts, start fabric and network down. Now this FabCar directory actually is just a script, which is this one, and the client code. So in Ethereum, we had seen how we wrote the client code. We connected with the wallet and then signed transactions using the wallet on the browser. Just now we did that for our smart contract. In Ethereum, it's something very similar, except that it's slightly more complicated. Um, and Ethereum provides ways for, as I said, all the typical scenarios that can operate in such an environment. Like you'll have to either enroll an admin and a user, or just enroll an admin. Then you can call your smart contract in a certain way. You can query your smart contract in a certain way. With Hyperledger, there's no cryptocurrency, so there's no transaction fees to be worried about. All transactions are the same, except there is some very basic difference in the type of transactions, which is very similar to the difference that we have in Ethereum, which is view transaction, which just reads the blockchain, and the write transaction, which updates the blockchain. So now what we'll do is we'll run this script. And what the script will do is it will basically use the test network script with all its parameters. It will first bring any existing network down. Then it will bring it up. It will create the up configuration. Using the up configuration, it will create the network. Create channel will create a specific channel by the name my channel. Then we'll use a certifying authority, and it will use the CouchDB database. So all of these parameters tell network.sh that the network has to be brought up in this way. And then again, we'll call network.sh, passing in deploy cc. Deploy cc will tell network.sh that we have to deploy the FabCar chain code. The language that we'll use will be parameterized. We'll pass JavaScript as a language parameter, and then the path where that chain code is. So having said that, it's basically a very thin wrapper over the test network. The only thing is it tells you how to execute the FabCar chain code also. So if you look at this documentation, you'll see what you need to do. We'll be in JavaScript, so we will be basically executing these steps. So let's start the script. We have to pass JavaScript as a parameter. So this step will take some time again on your system. If you're running it for the first time, we'll try to download various images, and we'll perform a number of steps. If you're running it a number of times, make sure that you bring down the network. There is a slight problem. Give me one moment. Let's perform the install one more time. There looks like a problem here. I'm running the install script one more time. Feel free to ask me any questions. It's going to take about 30 more seconds. So you can see it's downloading all the images for this specific version, which is 242. I had an older version earlier. Let's go back to Fabric samples, FabCar, start Fabric, JavaScript. Hopefully it's going to run fine. I may have to clean up. So what I mean by cleanup is I'll have to remove some Docker images because they are old. I have the commands for I do not have, see, so the conflict that I'm looking at is 2.4 and 2.2 existing together. What I might have to do is let me see if I'm able to run it now. Yep. So you'll see all of these steps getting executed. What you have to ensure is that you don't see any error in them. They're running multiple script commands. Um, you can individually run them after. So I've done the analysis of all the commands right here in this document. If you go towards the bottom, you'll see the start fabric analysis. And at each step, it does a bunch of things. By does a bunch of things, I mean it executes certain shell script commands. So the meaning of each command is written here, and what it's supposed to do and what the outcome should be. This execution also takes a good amount of time. What you have to be familiar with is the fact that after, let's say, this step of deploying chain code on my channel is complete, then whatever you want to do, Fabric is ready to do that, as in call the contract, execute parts of the contract. And the contract that we're actually running is this one, Fabcar JavaScript, this one, fabcar.js. If you do a quick walkthrough of this, the code inside this contract, all of this is boilerplate code. The important parts are, first, it has implemented a function called init ledger. Inside init ledger, it's creating a hard code of some data, JSON data. It's looping through that data, and then it is calling on the context that it got passed, which is what you'll be using for all Hyperledger commands. On the context, it calls stub and put state, which is basically the one line of code that adds data to the blockchain. And the data is a key value pair data. Through the loop, it adds this index I. It appends it to car. So this value will be car1, car2, car3. And then it, stringifies one element after the other and adds it against car1. So your car1 would be this, or maybe the one at the top, car2 would be this, and so on. So this is the init ledger function call. Then there is query car, which accepts a car number and the context, which basically calls get state passing in the car number. This car number would be car1, car2, car3, anything. And the return would be whatever this data is against that specific car. Then there is query all cars, which basically returns the data of the entire blockchain. Start key and end key are empty, which means it gives you everything back. Then there is create car, which basically creates a data like this and then adds it using put state. And then there is change car owner, which basically updates one part of the data that we've stored. So we can call all of these from our Fabcar client code. The client code is out here. Fabcar JavaScript. This is the client code. Now, enroll admin and register user, they are basically commands to create two types of users that are going to help us integrate with our Fabric environment. So all of this is boilerplate code. The only thing that can change is instead of admin, you might want to call your user something else. The execution of this code will result a file getting created inside this wallet directory. It will represent the wallet with its certificates and private key and everything. So we will run both of those. The important parts, or the ones that are of interest to us, are query.js, where we will be calling different chain code functions that we just saw. So in fabcar.js, we saw functions like query car, create car, query single car, and query all cars. We will be calling them in query in our query.js call. And all of this is boilerplate code again. You'll reuse it for any kind of query. What it does is it retrieves the contract just like it did in Ethereum after it gets to the channel and identifies a specific user. All of that is being done by the libraries provided by the Fabric network SDK files. So you've got the gateway in the wallet. These are the ones that, apart from that, you'll need path and file system, which are basically not Fabric specific. So you'll get the wallet using this wallets object that you got from Fabric SDK. And then you'll be using the gateway to create a channel, or really, get the handle to the channel. And then from that channel, you'll get the FabCar instance. And then once you have the contract, you can call anything on the contract. The same thing happens on, so that was a read transaction or query. The same thing happens on invoke side as well, except instead of evaluation transaction, which is what you had here, evaluate transaction, you'll have submit transaction. So it's calling create car because create car updates the state of the ledger. The rest of it is all the same. So let's quickly now run this code. First thing you have to do is you install the project. So again, the install is going to take a little bit of time. Then you can run your JavaScript files. First thing you have to do is enroll the admin. So as I said, enroll admin script is going to create a wallet file inside the wallet directory. And you'll have to register a user. I'm going to create a user wallet. Now let's try query. So it's printed all the car data that we had, car 0 with the record, car 1 with its record, all of that. You can also query a specific car. You just change the code here. Let's say you want to query car 4. So the way would be parameter has to be passed after the function name. Let's query car 5. Let's see what the result would be. So now you've got one single record. So these are evaluation transactions, which are basically evaluating the ledger state. They're not updating it in any way. Now on the invoke side, where you're invoking a transaction, what we can do is we can create another car. So I think we have cars till 9. Let's create car 10. And let's give it a name. Give it let's try to execute it now. This will take slightly more time than query. You'll get something like transaction is submitted, which is this log statement. If there's no error, you'll get this log statement here. Now let's query the cars again. So we've created car 10. Let's just query car 10. So you've got the data for our car right here. We can also update car 10. Let's say we want to change car owner of car 10. What you do is so we had Max earlier. Let's say we call it Nick now. Now let's query car 10 again. Now we see that the owner has changed. We can add more data. I think we did that, right? So again, what we basically done in the last 3 minutes is all that you have to do on Hyperledger. Everything else around building the network, getting the network scripts right, and all of that is a one-time activity. But it's a very complicated activity. All of it is inside these scripts that I was talking about. When you are building your project, a very simple and easy way to do it is just go to the chain code directory, make a copy of FabCar, or maybe just change the name of FabCar. Just change this index.js to maybe call it Pacific School Project or whatever your project name is. And then go inside FabCar. All you have to change is maybe you don't need init ledger. You don't want any initial data. Instead of query car, it might be queries, something else. That could be a data specific to your project, like query users or query my entity. So you basically have to update this, something very easy to do, and then just rerun the script. Start Fabric script. It's going to deploy your contract with the updates, and then you can change your Fabric client code from here and start interacting with your new smart contract. Having said that, we did rush over some of the things, like what is the meaning of this connection profile, and how does one update the name of the channel. So we'll be calling it my channel. So all of that is there inside this document. Feel free to read it and try to test it. One thing with Hyperledger one has to be careful of is like the issue that I ran into earlier. It doesn't work very well if there are more than one versions. It doesn't work very well if there are version conflicts. So you have to make sure you start from a clean system. There should not be some previous install, and you have to make sure that you have there are no conflicting environment variables. So usually what I recommend for Hyperledger is that you start on the cloud with a fresh cloud machine, like maybe go to Amazon and buy a free tier. Hyperledger can work in 1 GB memory as well. So 1 GB, 20 GB disk space, Amazon EC2 free tier will work fine for your demonstration projects. It needs your credit card, but it doesn't debit any money from the card. So you can use it for 6 months, after which your payment will need to start. So if your demonstration has to happen in the next 6 months, it's fine to start now. With Amazon, so I have no relation with Amazon. You can use Azure also. You can use any blockchain or cloud provider. One thing that's good with clouds is that if there is any environment conflict, you can just delete and create a fresh one. If you do it on your machine, you cannot delete your environment because there are other things that are there on your machine. So with that, we will be wrapping up a little early today. We have about 7 more minutes for any questions, not just about what we talked today, but about the overall session experience, any inputs, thoughts, or comments. Feel free to bring those up now. I'm sharing this link again for those of us who did not copy it yesterday. This document has everything about Hyperledger setup. Any questions, inputs? Can everyone hear me?
Yes, sir.
Okay, good. Give me a minute. I need to um, confirm something on the timings. Let me just resume. One moment.
Sure, sir.
Okay, so it looks like we have about a little less than an hour additionally. So we can take a look at Hyperledger in a little more detail. Whatever we did on building a very quick, network and sample code and everything, we can reuse, we can view it on a user experience using the Hyperledger Explorer. And although the commands for the Explorer are how you set up the Explorer are right here, but let's do a quick run through of that to see how you can use Explorer for, viewing the state of the blockchain and all of the different channels you've created in the transactions and everything. So what you need for that is again an empty directory. So let's maybe create it parallel to the Fabric samples directory. So what you'll first need to download, and we are going to just be running Explorer as an image, which is the easiest one to do. Just download these. So wget command basically allows you to download files that are there represented in these URLs. So just download these 3 files. Now what you need is, you've got these 3 files in your Explorer, which is the empty directory. We'll need some updates in these files. All those updates are also listed here. First thing you have to do is copy the .organizations directory from fabric samples test network. So you have these organizations configured here. Just copy them here. The copy is not going to be okay. You'll have to remove this. Then you'll have to change some permissions. So since Docker runs in its own user environment, so it doesn't allow my existing logged in user to be used for copying. So I have to change the permissions. For those of us who are familiar with Linux, chmod is a command that's used very frequently. Now I can copy organizations to the Explorer directory, which I just did. Now I've got organizations. The next thing that I have to do is update testnetwork.json. This part you can ignore. Fix the path of admin private key and TLS assert. To do that, go here, testnetwork.json. You have to change this path. This private key needs to be the right path. So you go out, organizations, peer organization, org1. Users, user1, MSP key store. All of this is the crypto material that I was talking about earlier that gets created as a part of setting up Hyperledger. Next is sign certs. So I think we should be okay here. Instead, we just need this much. So when you look at the MSP directory, sign certs, you've got the cert.pem, which is what you need here. So you've updated this path, you've updated this path. Then you have to fix the path of sign cert, which we did. Now you have to update docker compose.yaml. Explorer docker compose.yaml. The update is that volumes have to be defined like this. Then you have to set this, which is something that allows you to access Hyperledger using localhost. And you're good to go. Just run the docker compose command. Did I? So we have to be careful with the YAML file format. I might have made some Sorry about that. I didn't realize. Since when have I been muted? Can anyone remind me? Few minutes back. Okay. So hopefully you got the install part of it right. We just have to run through these steps for the install. And then once these steps are done, you have to bring up the Docker images using Docker compose command. And it comes up like this. What it's doing here is it's connecting to the Hyperledger Fabric network that we've already built in the other flow. And it is displaying everything about the network. So we've seen the dashboard. We've seen the network, which basically tells us that there are two organizations with two peers, one orderer, and then it shows the blocks and they are filtered by channel. You can actually search blocks, per organization. And you can go inside the block and look at the block data when it was created. Hyperledger has one transaction, one block per transaction. And then you can look at the transactions inside the block. So our transactions that we made are around the query for FabCar and creating FabCar. All of those details are there. You can look at what all inputs we passed. Like we created car 10, and then this was the data that we passed to it. So all of those inputs are available here, just like Ethereum showed you. Now you've got the transactions, you've got one chain code, FabCar, swooped up to one channel, and then it had 3 transactions in the past and a channel. So it's basically giving you an overview of your network. And you can also look at your credentials, as in your user ID by which you've logged in, which is basically the one that's configured in here. This is the credential that you have. So this is a very easy and convenient tool for working with Hyperledger from a monitoring perspective. There are a lot of other tools. I've not set them up on this network yet. So with Hyperledger, as I said, it is possible to implement Hyperledger in any use case, because it assumes a very typical sort of a hierarchy of implementing that use case. Like what would a group of organizations do? They will have to set up some policies, some users. They will have to define some assets. Then you'll have to define some processes on those assets. So when you look at the FabCar use case, that's exactly what it's doing. It's thinking about a car, and it's thinking about 2 organizations that have to create car, query cars, and so on. So when you think of your project, think of it from a modeling perspective first, as in, what is your domain? If let's say your domain is manufacturing, then what am I manufacturing? And the answer to that would be your asset. So if it is consumer durables like cell phones, so instead of car, you'll have cell phone. And then what are the processes that your domain has on your manufacturing process has on cell phones, like assemble, ship, brand. So those are going to be your functions. So if you look at FabCar, it's that template. You could have query cell phone instead of, or query a specific cell phone using the IMEI number or whatever, right? So you can basically reuse this same logic in a more complicated and more well-defined format for any domain. And when we talk about the client, so we're looking at this client that we saw where we are calling these functions like query. Now this client can be written for any kind of an experience. You could have this client written for an API that's exposed to cell phone to a mobile device. So this query can be seen on the mobile device, the results of this query. It could be on a web page. It could also be an input to another process. So with this Fabric SDK capability, what you get is the integration, and since it's allowing for SDK to be written in different languages, and integration is possible with any kind of technology stack. With Ethereum, also we've seen Web3.js, but there is a Web3.j also, which allows you to hook up Java environments or Java instances. So having said that, the underlying architecture for both Ethereum and Hyperledger is more or less the same, but the complexity at Hyperledger side is created by two factors. One is because it's a private blockchain, you have to set up everything. Two, it is modular. So different things have to be installed and they have to work together. And sometimes they don't, like earlier today. So that's one thing that makes it a little more challenging to work with Hyperledger than some of the other blockchain types. I just realized that I was not sharing my screen also.
Sir, the access has been already given it to you.
Yeah, I think when I went mute, I removed my screen share also. Let me just
Maybe,
run
sir.
through.
Sure, sir. Maybe it be possible.
Yeah, I just restarted my screen share. Can you see it now?
Sir, yes, sir.
Okay, good. So apologies about that again. Very careless of me. I was planning to finish earlier, then we have to do a little, extension. So we're talking about Explorer, and I'm pretty sure we missed all of it. The deployment part is something that I followed, exactly by the book, how it's described here. These wget commands and everything. The updates that I did were in the test network files, just as it's described in that document. And then finally, the UX we got was this one, where you could see the blocks, the transactions. So you got blocks that basically have a lot of details about them, when they were created, what was the hash and everything. The network, so you can see how many organizations are a part of your network. You've got two organizations, or one or two. Then you've got the blocks. Side blocks, you have the detail of the block, the transactions that you entered in the block. So we did a lot of queries on the FABCAR contract. So you can see the chain code that we called, and the inputs we passed are out here. So all of it is available. It's a very interesting monitoring tool. It's not used very frequently because usually organizations create their own tools for monitoring. But for a project that is either a demonstration project or a pilot project, this lets you very easily monitor your network. You can see the chain code that you deployed, how many transactions you submitted to it, all the channels that you have, everything. So again, taking a pause here, any questions? Okay. Let me talk about some use cases that the industry has for, let me see, for some of these private blockchains. So I had a very detailed use case deck that I created for I'll have to go off screen one more time, just one moment. So we've been talking about blockchains over a period of the whole week. Let's try to understand how the industry and the community at large is using it. So there are some domains that use blockchains very well, and they are able to basically utilize it to address some of the challenges that are there in the domain. We talk about, let's say, healthcare. It's a very heavily regulated industry, and what healthcare does is it needs to follow all the regulations that are specific to a country, which relate to record keeping compliances, data privacy, um, you know, drug and equipment manufacturing compliances. There are multiple such compliances that it has to meet. And something similar, like a domain like e-governance, again, all the laws that a government has to follow when it comes to um, things like citizen to government interaction, creating a record for a citizen, allowing a citizen to use welfare schemes, bunch of things out there. But the most easily um, adaptable domains are the ones where there are a lot of different people involved, like supply chain, and they have to interact while being unknown to each other. So supply chains where your consignment could be coming from a very different country, whose people you don't know, whose regulations you're not familiar with. You have to interact with them to take advantage of the arbitrage of price differentials, or demand and supply gaps. So supply chain involves a lot of things. Trade finance, where you have to finance your supply chain using getting a credit line from the bank, uh, usually called letters of credit, or tracking your consignments, making payments for them, custom excise documentation, and then all of the reporting and analytics that need to be done. So if we talk about, and I'll just run through some of this. If we talk about supply chains, let's see. One of the important projects, and I don't know, yeah. One of the important projects that is of interest is IBM's TradeLens. It's built on blockchains. You can do a quick Google and find out what it does. So TradeLens is a logistics and supply chain solution that utilizes IBM's own proprietary blockchain. Now, the interesting part about TradeLens is that it operates on a blockchain that other solutions can natively integrate with. Like you have your Hyperledger instance, you start synchronizing it with another Hyperledger instance. That's all possible. But what TradeLens does is It's able to say, okay, if you've got a Hyperledger instance, you can hook up with TradeLens. And one very important use case that TradeLens solves for is high seas auctions. So when it comes to shipping, especially cross-border shipping of cargo goods, then or shipping of something like a commodity which gets traded very frequently, like crude oil, then while the crude oil is in transit, its ownership changes because um, as the cargo moves from one country to the other, it is possible that the price of crude oil and the requirement of crude oil changes in such a way that it becomes more profitable for another country or oil company to buy it. And primarily because it's so expensive to transport crude oil that if it is nearer to a port which is not its destination, it might be more profitable to still sell it to the government or the oil company of that port if they are able to kind of get into an agreement with either the shipping company or the oil company that's transporting it. So a lot of auctions happen during transit also. So TradeLens allows for a very quick and seamless change of ownership, integrating with payment systems, settlement systems, getting the data available in real time. At the same time, what TradeLens is also able to do is integrate with some IoT equipment that is used for monitoring and measuring um, the vessel which is carrying that um, oil. So what happens is that um, the quantity of oil that's traveling or is being transported is not measured by some metrics that in this cargo is this big and so forth. They have a way in which what is measured is how much has the ship sunk after it's been completely loaded, and that height along with the nature of or the brand of the vessel, that reveals how much oil is there, and that needs to be done transparently. So there are equipment that does it and makes that data available. TradeLens integrates with that equipment to ascertain to a potential buyer that this much is the oil and you can quote this much, and all of that is done on the blockchain. So it's a very interesting use case. You can take a look at some of the features through that tool. They don't have the tool anymore. Earlier used to have a demo, maybe a video is here that you can take a look at to understand how it works. But having said that, there are some other use cases that are of interest also, like BlockVerify, again for supply chains. Let's take a look at, so this is a dated deck. Not sure if all of these projects are running or not. This one seems to be down. Some of these projects, I mean, they start off and then they're not able to get the traction, but TradeLens is something that has survived and it's finding a lot of traction. There is, so if you look at, I mean, it's easy to kind of see. There are so many different projects. I mean, the top one being IBM's supply chain solution that basically do something similar to how what I described for supply chains, apart from some backup and logistics work like enabling easy documentation or allowing for trusted audit trails. Now, shifting gears and going to a very interesting domain altogether. I'm sure we discussed NFTs to some extent in our earlier sessions, but NFTs have very recently become very disruptive to the art industry. And the very fact that you can represent um, a token to look like, you know, a digital mapping of any content that can be represented as stored digital media, that is very compelling. There are projects like OpenSea and Rarible that are marketplaces for NFTs that allows, you know, any creative artist to curate their work and then sell it and get the right exposure. And all of these projects, they're basically doing something very similar. So media and art industry being disrupted by blockchains very substantially very recently. Now, some of the other use cases that I have are financial. So when it comes to lending and credit, getting a loan is basically dependent on your credit history and how much you know how much trustworthy does your credit history reflect you to be in terms of repayments. And that is the reason why peer-to-peer lending, as in personal lending by one person to the other, is it's a very risky thing, because one person who's lending does not have a way to ascertain the credit worthiness of the person who is taking that loan. With blockchain-based peer-to-peer lending, repayment becomes guaranteed, or submission of collateral becomes guaranteed. So the loan basically becomes risk-free because it's a blockchain. No one can stop a repayment transaction, or no one can stop, the collateral of a loan to be used for removing the risk against that loan. So blockchains have kind of disrupted lending and credit finance industry primarily because of their trustworthiness. Something similar is happening in insurance, where insurance fraud is a very big problem. What happens is that someone who understands how insurance works is able to prove things like damage to property or damage to anything that is insured multiple times. And since data is not shared between insurance companies, this becomes a problem for the entire industry. With blockchains, what can happen is that there becomes a universal data set. So when we're talking about blockchains, data can be synchronized from one organization to the other. So this universal data set, what it can do is it can make an insurance company make intelligent decisioning on a certain kind of claim that comes in. Data that they did not have access to earlier can kind of tell them that this claim has been filed multiple times, and then they can flag that claim accordingly. So whenever there is a need for data universalization or data decentralization, blockchains can come in and help. And insurance is just one example. There is the whole lending industry that is, dealing with fraud. There is citizen welfare schemes that are dealing with fraud primarily because they're not accessing the right data, and data is not available. And blockchains with their premise of having like some sort of a synchronization process for data that's created at one place to be known and available at another place. That is very compelling. Makes for a good argument to have blockchains. So any other questions, comments or thoughts about what we've been talking about? All right. So there are, so IBM again is mostly in everything when it comes to blockchains. IBM's kind of, especially when it comes to enterprise, IBM has a lot of use cases for different domains, primarily for enabling like a universal solution that basically works for any domain. So insurance, then if you want to look at what they're saying about insurance, one very important thing with insurance is that there's a lot of documentation that needs to be maintained, and blockchains, with their universal identity, it can help. And then the very limited use case that I explained has far-reaching consequences, like risk handling capabilities improve if you have more data. Claim payments are more streamlined if you're able to identify a person more universally. Audits become easier. So, and when you're basically settling a claim, there are different entities involved, not just the insurance company. There's a verification company, there's a payment company, sometimes banks, and there needs to be a reconciliation. So if there was like some kind of a universal blockchain that had all of these entities on the same database, it would be so much easier. That's exactly what they're saying here. Coming back, some very important companies that are utilizing blockchains. Quorum is a very important private blockchain, which is a fork of Ethereum. It's being used by State Farm and USAA. They both manage insurance claims on blockchains. Now, some of the other use cases are very focused in the sense that they are relevant to any domain. It comes to, say, supply chain or manufacturing, retail, which is payments. So you have to transfer money for any kind of business activity. And Emergent is again a Singapore-based outfit that has tried to digitize the payment using gold. So we talked about stable coins using commodity asset backing, which basically means you can set up some gold deposit and then release coins saying that one coin is worth so many grams of gold, so that will always have a stable price. And anyone can use that, coin to make payments. Not a very difficult concept to conceptualize, but the fact that you're using it for payments, using your gold for payments was not something that was possible earlier, because you will not take like a gram of gold and buy something. You'll usually use some currency. So this kind of an initiative makes it possible to monetize your gold deposits. Finance commodities. Let's not talk about this one. IHS Markit is a financial technology firm, so fintech, and they are using a smart contract framework called Stacks, which allows them to handle the payment when it comes to loans, as in how do I make payouts. And they've used it very optimally. They're able to honor payments and uh, make payments on time and keep a record of payments. So when it comes to payments, it can fit into any domain. And the very fact that blockchain started off as a payment transfer system with bitcoins makes it very easy for one to relate payments to blockchains. There are so many solutions that are just doing payments as a part of, you know, uh, um, or who just using blockchains as a very small part of payments, where you create a payment transaction, save it on the blockchain just for analytics. You're not doing any money movement on the blockchain. So there are projects like that are doing it. Payment technology is very vibrant because there are a lot of new technologies that are making payments easier for um, a person or a company. And technology focused outfits like PayPal, they coming up with um, a payment experience concept called ambient payments, where um, when you have to make a payment, you shouldn't even be aware of it, where payment becomes your ambience. Let's say you have to pay for, and this is more of a person to person payment or bill payment, assuming that you have to pay for coffee. Um, the very fact that you're getting coffee, it's obvious that you realize you have to make that payment. Then it becomes very intrusive for you to either pull out your credit card or do anything related to that payment. So an easier way is that you integrate something like blockchain payment system to an IoT device that is able to send credits on your behalf automatically. And that concept, when applied um, in situation where all kinds of money movement is done on blockchains, is made possible by the fact that instead of a wallet, you could have an IoT wallet. That IoT wallet could be either allowed to hold some kind of credit, or could be something that authorizes a credit and makes payment experience to be as unintrusive as possible. Again, something that can only be implemented by blockchains. So that's kind of some very, very focused and unique examples of how blockchains can be used. I know that as an engineering school, there might be a lot of projects that as faculty you have to analyze and evaluate. It is always good to suggest blockchains wherever there is data authorization, data analysis, data capturing that is happening, because that will enrich the project. It improves the quality of data if you have trusted data there. So having said all of that, again, any questions, inputs? So we are coming to the top of the hour. Feel free to ask me anything. We have this opportunity. We're all gathered here. Be good to have some sort of a discussion as a closing exercise.
If any participants have any doubt or the question, feel free to ask.
Good morning, sir. Sir,
Good morning.
in agriculture sector, how we have to use this blockchain technology?
Yeah, that's a great question. So there is a concept called provenance. Provenance means that how do you prove that a certain food item or certain consumer durable, non-durable that was manufactured from agriculture inputs was created by the right quality of agriculture raw material. And the way to do that is if you're able to capture the journey of that manufacturing process, right from the growing of crop or the plantation. And there are numerous examples. If you just Google provenance agriculture, numerous examples, dairy farm products, crops, um, vegetable produce, all of them starting their journey of providing the raw material for manufacturing on the blockchain. um, I think there is a project in somewhere in Europe where they hook up a cow to some IoT equipment that keeps sensing the output that is produced by a certain cow and referencing it on the blockchain, so that the cheese that is produced can be traced back to where the cow was and which farm or what location was the cow kind of feeding, so that they are able to ascertain that uh, the right uh, the right input or raw material was there for creating that cheese output. Hopefully that answered it.
Okay, sir.
Thank you very much, sir, from your continuous support from past 5 days and give us supportive knowledge in the context of blockchain and its eavesdropping technologies. We are very thankful to you, sir.
Thank you all for joining. Have a good day. Bye.
Thank you, sir. Now we are moving towards the session 2 that is conducted by Dr. Keyur Parmar, sir. Sir, am I audible to you?
Hello. Yes, you are audible. So
Yes,
thank
sir.
you.
Sir, you can continue. Over to you, sir.
Yes, yes. I think so. My screen is visible and I'm audible. So please say yes or no and then we'll start.
Yes, sir. It is visible and you are audible too.
Okay, so um, good morning, everyone. Today we are going to discuss one very interesting problem. So far in this workshop, starting from the very first day to today, like you must have learned many things related to blockchain technology. And when we say blockchain technology, what is the most important thing in the blockchain technology? Like what was the invention that is being done by the Satoshi Nakamoto? So So the main thing that Satoshi Nakamoto has started with is there is a problem that is known as double spend problem, and that problem he solved. And as he solved this double spend problem, then uh, they have started and that cryptocurrency named Bitcoin. And just within a few months after that currency, Bitcoin, many people have created their own alternative currencies. For example, Ethereum is also there, and some other cryptocurrencies are also there. Ethereum is also a platform, and many other digital currencies. Now, soon after that, like in 2010, he has solved this problem, that is double spend problem, and Then they have created number of cryptocurrencies. Alternatively, they have found out that this particular concept of double spend and the blockchain is not something that is only limited to cryptocurrencies. That is not only limited to eliminating the trusted central authorities such as the financial institutions, for example, the bank, but this cryptocurrency can be used on this particular technology, blockchain, and the solution of that double spend, that can be used in many other scenarios. For example, the supply chain. So, for example, in my previous talk also I have discussed about the Amazon and some other uh, uh, private firms. So those provides the services to their clients, and basically they are not the connection is not peer to peer. So we are not directly connected to the manufacturer or whoever the suppliers of those goods are. Basically, we need some sort of, in the supply chain, we need some sort of a central authority that both the party trust. So in this case, the client is, we are the client, and on the other hand, there is going to be somebody who is manufacturing those products, and in between there is a Amazon and something that provides that sort of services. So we know that it can be used to improve the supply chain. It can be used to improve the, for example, suppose the same technology, the technology that we are talking about, blockchain, can be used to decentralize and make this academic process more transparent. So suppose one of my work with my student was on academic transcript system. So usually what happened, for example, suppose if you need a transcript from your institute, so I assume that there are going to be some of the students who are doing their BTech or MTech in the particular institute. So whenever you need a transcript from the institute, your institute, somebody is required on the institute end who is going to verify the marks, like whatever the transcript copy that they are going to print. How do we verify that that transcript is genuine? So that transcript needs to be printed, and it must be verified with the genuine data that is available with the host institute. Now, suppose if the institute is old enough, for example, SVNIT, then in this 40, 50 years, there are a number of students who have passed from the institute. And so if they want to find out some data related to a particular student who completed his BTech or MTech in, for example, 2005 or something, then it takes a significant amount of time to find out the data and then to match that data with the actual data, and they have to verify each and every marks of different subject, because you know that in the transcript all the semester, all the marks, name of whoever that person's transcript is, and all those things are mentioned. So that thing need to be meticulously checked, and then the final authority, like whoever the authority in the institute, for example the registrar or something, he is going to sign that transcript to verify that whatever this printout or the page that we are giving, that is equivalent to a mark sheet, and that is equivalent to the physical hard copy of the mark sheet, and that transcript, that people are going to take it from the institute, pay the required fees, and then they are going to send it to some country, for example the USA or some other country. So what we can see from this scenario is even the simple thing, for example, taking asking an institute to provide the transcript. If we have completed our degree program from the institute, that thing will take the time, like providing the transcript means registrar or somebody with all the other activities that they have to do in the institute. Other than that, they have to find out all those transcripts, they have to verify the marks, they have to sign it, and so on. And for that they are going to collect some fees, and then again, so that fee is also to be paid by the student, and student is going to send that transcript to some foreign university, and so again there is going to be a charges of courier and other stuff. So it adds a cost and the time of the registrar or the student and all those things. So two things are there, like is it possible for us to use this blockchain technology to save that time and the cost that is invested by the institute and the student, so that if once a student passed from the particular institute, we are going to give him some sort of a digital token, and using that token he'll be able to share that transcript digitally to many other universities without paying any additional or extra cost. So whatever the cost that is required from the institute side, that is going to be a constant cost. So for example, suppose one student is going to different universities and he wants a transcript for that. So he has to ask the university to provide 10 different transcripts. Now, if he is not asking the same thing at the same time, but suppose if after a few months break, he asks the same thing again to get the transcript, then every time the manual work will be added. So that manual labor is linear. Linear cost will be added. Rather than that, if we say that if only the institute do some one-time work and then append those data or upload those data to the blockchain, and if we can use that data in future in a secure manner, so it will be a very good thing to do. So what are the properties that blockchain can help? So suppose, I think you must have heard about the properties of blockchain. For example, blockchain is immutable. So whatever the data that we are going to upload it to the blockchain, nobody will be able to tamper with that data. And that thing is very important in this case. So suppose if the transcript is uploaded to the blockchain by the institute, so that will be a one time overhead. But so for example, whenever the degree will be issued to the students, like institute is going to upload those degrees to the blockchain, and so it becomes immutable. If we are using the blockchain technology, and institute has that overhead, extra overhead in terms of time and the effort will be reduced. And on the students end, if the all those transcripts are available on the blockchain, then they can easily ask other people, for example other universities, for example for some foreign universities and so on, to verify the transcript from the blockchain online, and it will save the cost and the time. So all those thing is something that we can do in the academic environment also. The same thing is with many other environments. Like every time, whatever the things that we see in the real world, most of the people are service providers. For example, suppose if you think about the Uber, or for example GoIbibo and many other things. So what are they doing? Or for example Ola. So what are they doing? So basically they provide the services. They are not owning the vehicles, and the clients are different. So there are vehicle owners, or the drivers, and there are the people who want to drive from one location to the other location. And Uber or some other Ola or some other service providers, they only provide the services. So what we can do using the blockchain technology is, basically using the blockchain technology, we can eliminate these service providers. Now what we are going to get if we eliminate the service providers? So basically, when we eliminate the service providers, what we are going to get, if we'll facilitate the peer-to-peer transactions. For example, suppose one person wants to go from one location to the another location, and instead of going through some app that is created by some sort of a central party, like the, for example, the name that I have given, instead of that, if we can decentralize it, then what it will help us to do is, it will reduce the cost, and both the client and whoever the driver, both will get that share, like whatever the advantage. In addition, the decision making will be decentralized. So currently, whatever the decisions that are taken are something based on some sort of a central party, like whatever that organization is, the top management, like few people of that top management, for example 10 people are going to take that decision, whether to go with this particular, like this policy or that policy. And that policy may be, for example, suppose somebody say that we are going to charge a user 10% extra for this trip or something. So that decision is going to be taken by some sort of an authority, or 10-15 people. So that decision is also centralized. If we are going to have a decentralized system using the blockchain technology, so it will not only helps us in terms of financially, but it also helps us to in decision making. Like decision making is also completely going to be transparent and honest decision making. So all those 100% nodes who are the client and whoever the drivers are, if they gave their vote on a favor or against some decision, and based on that, if there are 51% or more participants in the network, if they agree on something, then that decision will be taken. So this particular thing, like the double spend problem that I'm going to discuss, is not only limited to cryptocurrency part, but rather it is in many other scenarios we are going to see. Yeah, so you can turn off your mic, so it will
Sorry for the
help me.
interruption.
Yeah, so the double spend problem is not only limited to that thing, that is uh, cryptocurrency, but the same problem will be there if we are using the blockchain technology in anything, like for example in academics, or in supply chain, or in agriculture, or in governance. So suppose you have seen the many blockchain related projects, mostly in Andhra Pradesh government, there are a number of projects related to blockchain. The similar thing is in the Kerala. Even the central government, I think you must have heard about that, they have imposed some sort of a tax on the cryptocurrencies and NFTs and other stuff. So it means they are not denying that this technology, and now as they have imposed some tax on these things, in future what we are going to see is number of services that will be decentralized, that will be provided by some sort of a system, and those decentralized services have their own advantages over the centralized services in terms of accountability, in terms of decision making, in terms of cost, and all those things. So how do we have all those services? So for that, we have to solve this problem, that is double spend problem. Now we don't have to solve this problem because somebody else has solved this problem for us, and that person is Satoshi Nakamoto, and we are going to see in this talk how exactly we can use what exactly this problem is and how to solve that problem. So how to solve that problem part is something that we are not going to see, but basically we are going to see roughly what exactly that problem is. This is a goal of a double spend problem. Like when Satoshi Nakamoto was researching about this topic in somewhere around 2008, the computational problem that he has focused on is this problem. So I think all of you are from computer science background, and you know that basically in computer science what we do is uh, so usually when I ask some other people like who are not from the CSE background, if I ask them a question like what we are doing as a computer scientist or computer science students, and their answer is we do programming. Now it is not a correct answer. Yeah, we do programming, but the programming is not the goal. Programming is not the objective. Why do we write a program? So that thing is the objective or the goal. And so basically what do we do in computer science? So we basically solve computational problems. So there are going to be computational problems. In order to solve that computational problem, we are going to write down some sort of an interesting algorithm that is going to be efficient. And that solution is something that as a computer scientist, what we do. And once we have solved that problem, we are going to implement it and then program it or something and so on. So basically our goal is not only to program something. First thing is we have to find out what to program, and that finding out that thing is our objective. So in 2008, Satoshi Nakamoto was focusing on this problem, that is double spend problem, and the goal was to solve the double spend problem. And basically why he want to solve this double spend problem is because of this reason. So since 1980s or something, people are trying to decentralize the currency. So this idea is not very new, like they want to decentralize the currencies. The idea was very old, and we know that we are having a paper currency and we are having a smart cards, for example, the debit card and credit card and some other card and so on. So there are different forms of currencies we have used, or we are using the online banking and so on. So in all those different forms of currencies, what we require was some sort of a central third party, the trusted third party, for example, a bank or Visa or MasterCard or something. So some central third party is going to do something on behalf of us. So in this case, what was the goal for the Satoshi Nakamoto? So the goal was he wants to facilitate the electronic payments, but not through some sort of a central agency, like for example, Visa or MasterCard or Paytm or bank or something. Because if even if it is a Paytm or some bank or Visa or MasterCard or something, they are the central trusted third parties. They manage the things and they facilitate the communication between the client and the server. So here, this is a simple goal. We want to eliminate the trusted third party, and uh, if we eliminate the trusted third party, the issue is then there is going to be a double spend problem. And so how do we solve the double spend problem? So that we'll be able to have electronic payments without the trusted third party. So that was the goal. So let us see what double spend problem is. So the main question is, what is a double spend problem? And so basically a double spend problem is similar to counterfeit currencies. So I hope all of you understand the counterfeit currencies, and you have seen many cases. Like if you regularly read the newspapers, we see the counterfeit currency related cases every few months. So there are people who are going to print the currency notes in a fake manner. Like, so it is not a genuine currency. They are not authorized to print it, but they are going to print it, and that currency looks like exactly the same original currency notes. Now that is the counterfeit currencies. And uh, what can we do to prevent that counterfeit currencies? So government tries to do different things to prevent the counterfeit currencies. For example, they embed some sort of they use different ink and different paper and these and that, and all those things they are doing to make sure that whatever the currencies they are having, we see the images of, for example, in our country we see the images of Mahatma Gandhi and some other numbers or something at specific locations in the note. So, and based on that, we'll be able to identify that note as a genuine or fake. And if somebody is printing the notes using the regular printer or some other regular papers, then they'll not be able to have that exact currency. But whatever those people who are having this sort of counterfeit currencies, they are doing this thing, printing and something. They also try to copy it, mimic it, to make it exactly look like a counterfeit currencies. The same thing is not only applies to counterfeit currencies, but for example, the fake degree certificate. So whatever the university provides you a degree certificate. Now, the degree certificate has certain informations like the registration number and other stuff and so on, and somebody has signed it. Now, if we do not ask students to get the transcript from the institute, and basically whatever the certificate that they gave us, or checking that physical certificate, it is really nearly impossible to validate that certificate, whether it is a genuine certificate or fake certificate, because nowadays everybody is using the computers and everybody understand that how to edit the documents and so on. So and getting that printed pages and that sort of thing is not something difficult. So all those problems are there in the real world also, like the fake degree certificates or fake currencies or all those things. And what we want to do is we want to use some sort of we want to provide the technological solution to solve this issue. So again, we are not going to completely eliminate this problem, but we want to solve this problem reasonably. So here the double spend problem was even there when we are not having that digital currencies. And that problem was something like a counterfeit currencies. So in a double spend problem, the adversary create one or more fake copies of the original digital coin. So digital coin, when we say, means in your brain, you have to think the digital coin as in terms of a computer is whatever the computer processes, it is in the bits 0 and 1. And so when we say a digital coin, we are going to have a number of bits. For example, in this case, let us say that there is going to be a 512 bit number is there. That number is going to be a one digital coin. And if we say that this number is going to be a one digital coin, then I can, and if I have that number, then I'm going to copy those bits and I'm going to paste it to 10 different people. And so 10 different, the same coin will be with the 10 different people, and then those 10 people may share with 10 other peoples and so on. So then there is a no way to prevent the double spend, because then anybody is going to create as many fake copies as possible in order to increase their wealth. Just like the counterfeit currencies, like if you have a one genuine copy of the note and then you are going to print that note and create a fake copies, or similar to academic transcripts or something. So that thing is there, and our goal is to prevent this. So whatever that double spend is, if somebody has a digital coin, how do we prevent someone to creating the copies of it, and then we'll be able to circulate those copies without being detected by the other end. So that is the goal, and that we are going to focus on in the today's talk. So why don't we have a double spend problem when we use online banking? So can you say the answer? Like, this will be not very difficult answer. So I hope you understand the double spend problem. So please say yes or no, like if you understand the double spend problem, and then can you say that why this problem is not going to be there in the online banking?
Because, sir, two-way authentication are there with the customer and banking server.
Yeah, so that two-way authentication we can even have in a peer-to-peer connection also.
Yes.
For example, suppose if I'm trying to access the Google server, then there is a no central authority between me and the Google server, but there is going to be a two-way authentication. So we can authenticate it in two ways. Here, what stops the double spending in online banking? Or why don't we have that double spend problem when we use online banking? So basically, we don't have a double spend problem when we use online banking. The reason is there is going to be a bank in between. So for example, suppose if I say there is going to be a for example, I am trying to connect with my bank, and what I want to do is I want to send the money to maybe some person like Alice or something. So for example, if I have to transfer the 1,000 rupee to Alice, uh, whatever the communicate, first what I have to do is I have to register with my bank. And if I have a bank account, or if once I logged into my bank account, then only I'll be able to transfer the 1,000 rupee to Alice. So it will not be peer to peer in the first place. So in the online banking, what happens? I logged into the bank account, then I transfer 1,000 rupees information. So whatever the thing that I'm going to do is I'm going to generate the transaction. So for example, first thing is log into the bank. And then the second thing that we are going to do is we are going to generate a transaction. So what information that transaction is going to consist of? So it consists of the my name, like whatever my bank account number, my bank account number. And the other thing is going to be Alice bank account number. So, and then the amount that I want to transfer from my bank account to Alice bank account. So that thing is being done. Two things is being done by me. First thing is I have to log into my bank account, and then I have to generate a transaction using different options available in that portal. What bank is going to do? So bank is going to, if whenever I try to log into the bank account, bank is going to verify the details related to my login. And if that information is correct, then bank is allowing me to log into the bank portal. Then the second thing is whenever I'm going to generate the transaction and send that transaction to the bank, bank is going to verify that transaction. So the second thing is being done by the bank. So what bank is going to do is verify the details of the login, and whatever the transaction that I have generated, a bank has to verify that transaction. What do we mean by verifying the transaction? So bank is going to check that in the transaction, whatever the account number mentioned is correct or not. Because suppose if you are successfully able to log into the bank's portal, and whatever the information you are sending, if you edit that packet and you change the transaction, and in the source you send somebody else's bank account number, then it will be, money will be deducted from somebody else's account. So bank do not want that thing. So bank is going to verify the transaction, and bank is going to verify all these details, like the person who has logged into this bank account, the account number is the same as of that person. Then the bank is also going to verify the Alice bank account number. And the third thing bank is going to verify is the amount that is mentioned in that transaction. And how exactly it verifies the amount. So bank is going to check whether the amount is available in this particular account, like my account. If I have 1,000 rupee, then I'll be able to transfer 1,000 rupee to somebody. If I have only 1,000 rupee in my account, but if I'm trying to do the transaction of 10,000 rupee, then bank will deny it. Even if I'll try to do a transaction of 1,001 rupee, bank is going to deny it because I don't have the money in the first place. So bank is going to verify this transaction, like verifying that whether the account numbers are okay or not, and then it will check whether I have that required money or not. And if I have the required money, then bank is going to after verifying the transaction, bank will just complete that transaction, means transfer the money uh, or transfer the money in the sense, for example, deduct the money from my account and add it to Ali's account. So this thing will be done by the bank. Now, this is what we do not want. Like in the case of a blockchain, what we want is, we want to eliminate the bank, and we want the Alice and um, me, Keir, want to exchange the currencies, or exchange the information, or exchange some sort of a services, for example, the car or something. And uh, we want to do that thing in a peer-to-peer manner. There is no in between, there is no intermediate party who does this thing. So basically, there are few things that is required to be done. First thing is verifying the transaction, and if the transaction is valid, then we have to take some action. Now, when we say that we are going to eliminate the bank, then somebody else has to do that thing. So here the question is the question that we have started with is, why don't we have a double spend problem? Why this person is not able to do the double spend? Is because there is a bank in between, and bank verify every transaction and see that whether the person who is doing that transaction has a the amount in his account or not. If that amount is not there in the account, then that transaction will not be allowed. So why don't this question's answer is because in the online banking also, we are having a bank as a central trusted third party in between the client and the whatever the recipient is, and that's why that thing is not allowed or not possible. So the answer is a trusted third party. For example, there are trusted intermediaries such as the financial institutions, and because of them, they verify that transaction, and that's why the double spending from one particular party will not be possible, because every time that party is trying to double spend something, if the uh, bank is going to deduct my money from my account and then add it to the Alice account. So uh, if I'll never be able to do that sort of double spend, because bank has already deducted it from my account. So I don't have that money then afterwards. So then I'll not be able to do that double spend. So because of that, now therefore a double spend is not possible in the online banking. The next question is, what is the difference between the cryptocurrencies and the digital currencies? And the answer is, in the cryptocurrencies, we do not have a trusted intermediaries. So unlike digital currencies, cryptocurrencies function without the trusted intermediaries such as bank. So in this scenario also, what I have said is, as these parties want to communicate and there is a bank as an intermediary, what we want is we want to facilitate the peer-to-peer communication. So suppose if you are using a torrent networks like BitTorrent or something. So one person is transferring the file from his computer, and that file will be received, or whatever the packets are, whatever you are downloading, for example, a movie. So that movie will be downloaded not from some server, but from somebody's computer. So that somebody's computer is going to have that movie, and that movie will be downloaded from that thing. So in the bit torrent, whatever the torrent you are using, that supports that peer-to-peer file transfer. So that peer-to-peer transfer is not something new, but the peer-to-peer transfer has that problem, the double spend. So suppose if you downloaded that movie, and then you can also share that movie with 10 other peoples, and the original person also share that movie with 10 other peoples, and that are double. In the case of movie, there is not going to be any double spend, because even if we have 1,000 different copies of that movie, we don't care. But suppose if we have 1,000 different copies of the currency note, then it is going to be problematic, because for the same value we cannot have 10 different copies. And so uh, concept of peer-to-peer communication is already there. The only thing is, in the case of this currencies, it is not something suitable because of the value associated with it. The same thing is with land transfer. So suppose one party wants to transfer a land to some other party, we need somebody, some intermediate uh, uh, authority or the organization that facilitates one party to transfer the land to the other party, and that does all the record keeping. And we can also use blockchain technology to eliminate that party. So here the answer is uh, 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 we need to eliminate the trusted intermediaries. So the question comes here is, what are the reasons to eliminate the trusted intermediaries, such as a financial institution or maybe some government department who is facilitating the land transfer from one party to another party, or maybe the here when we in the case of academic transcripts, what I have discussed is there is going to be the institute registrar or institute who is going to produce that transcript and all those things. So if we want to eliminate that party's role, so ultimately we don't want to eliminate the party, but rather what we want to eliminate is that centralized decision making, and we want to eliminate that sort of some other things, for example the cost and time and other stuff. And so how do we eliminate this trusted intermediate adversaries, and what are the reasons, like why we want to eliminate them? So those reasons are interesting, and that we are going to see next. So basically, the trusted intermediate adversaries, such as the banks, have the following weaknesses. For example, the high transaction cost. So suppose you have to consider two scenarios. For example, suppose we are saying that I have some coins, like the physical coins on my hand, or maybe say some sort of a currency notes or something. And I transfer that notes or the physical coins to somebody. Like suppose if I go to a restaurant and I pay 500 rupees to that person. So how many rupee will be received by that person if I pay him 500 physically? Will it be same, or is there going to be some sort of a difference? It will be
So
same.
it is visible.
So if I pay 5,000 to somebody or 500 to somebody, does other party, if it is a physical note or a physical currency, like whatever the coins or something, then that party is going to receive the same amount of money. There is not the value will not be when that money is with me, that it has some value, for example 500, and when I give it to that party, that party also has that note or that currency has the same value 500. Whenever they exchange hands, the value is not going to be reduced. So it means there is going to be no transaction cost. For example, the same thing is when I go to buy vegetables or something, the whenever I give the money, whatever the money's value is, that remains the same, because there is no service provider in between. I'm directly purchasing the goods or the vegetables or something from that party, and they pay me back. So So they give me the vegetables and I give them the money, and so that value will be there and there is no transaction cost. um, do you think that we are going to have a transaction cost when we are using online banking?
Yes, sir, some amount of.
Yeah, so whenever we are doing, for example, suppose if I am booking my ticket, railway ticket or something, then there is a bank is going to impose some charge. So suppose if the ticket is of 400 rupees, then bank is going to say that for this transaction, there is going to be 10 rupee extra charge. Or the same thing is with other service providers. Whenever you are trying to access, use their services, they are going to impose some very small amount, but they are going to impose a charge. So this thing was not there previously, but now as like whenever we are exchanging that currency physically, then what happens? Now that thing will be added when we are using the online banking, or even in the if we are not using the online banking but the offline banking, then still that transaction cost will be there, and that transaction cost is not there when we are doing it physically, like the exchanging the currency from one hand to other. The second disadvantage of this, and this particular transaction cost is collected by this trusted intermediary. So one good reason to why we are not interested in this trusted intermediary is because of this additional transaction cost. The second reason, interesting reasons are transactions are not real time. So suppose if I'm going to some store in the nearby place and I give them 500 rupee and buy some products, whatever, whenever I give them the money, that thing is real time. There is no extra time or something that it takes to transfer the value from my end to the other party's end. So there is not going to be any additional time whenever we are doing that transaction. Whenever we are doing the online transaction nowadays, the online transactions are very fast, but not real time. Real time means not immediate, it takes some time. Why it takes time? So because bank has to do three different things, like the verify the log ID and the transaction, and then deduct the money from one account and add it to the other account, and so on. And if we are talking about the different banks, if it is in the same bank, then this process is, because of computers, this is very fast. But suppose if we are talking about different banks, then it takes some amount of time and if we are transferring the money from one country to some other country, it takes more time. So transactions are not real time. The same thing is not there when we are exchanging the physical currency, for example, the coins or something. So suppose if I give somebody some coin or something, that is a real time, means he immediately get that value. So those things are there. So this is again why they are not real time. So because some intermediate party needs to process that transaction, and that processing time is something that is being added, and that time will not be added if we facilitate the peer-to-peer exchange of goods or services or something. So that transactions are not real time when we are having a trusted intermediaries. The third thing is very important, and that is anonymity. So suppose if I'm buying a vegetables or something, and when I give the money to that person, this thing remains anonymous. Means other people other than the me and the person from whom I am buying the vegetables, only those two parties are aware. But bank and some other organizations are not aware that what vegetables I bought, or what products I bought, or what books I'm reading, and all those things, or which car I which car I have just used to go from one location to the other location. So my anonymity will be there. In this case, when we are having some sort of a trusted intermediaries, those intermediaries are aware about the details of the transaction, and so our anonymity will not be there. So other than these two parties, like in this case only the Kure and the Alice are aware about the transaction. If we have some sort of an intermediary, then that intermediary also is going to be aware about all the details, like this party has transferred the money to this party and so on. So that will not be a very good thing in terms of my privacy, and the same thing is with the recipient privacy. So that is also because of the trusted intermediary, because when we are going to have a trusted intermediary, um, anonymity will not be there, and that trusted intermediary will be able to have that information. So do we have any questions so far?
Hello, sir.
Yes.
Sir,
Yes, you
sir,
can
if
ask.
we are talking about the anonymity, sir, the neighbor node will be affected with it or not?
Hmm? So can you repeat the question?
Sir, if you are talking about the anonymity,
The part that I have
if
heard
there
is
is a number of,
hmm?
if there are some neighbor node are also there, they will be affected or not?
No. So when we say we are facilitating the peer-to-peer communication, what we want is, and other than the two parties who are exchanging the information, the other parties, the neighboring nodes, they must not have that information. So
Okay, sir.
not only the neighboring nodes, but some intermediate neighboring nodes is a very very big thing. What we do not even want is that service provider, for example the bank or some other
Yes, yes.
service providers. For example, suppose you are applying at some degree program in the United States or something, and some institute, for example NYU or something. So if you are applying to NYU, and why that information should be with your present institute?
Okay, sir.
Just because when you apply for a transcript, you have to give that information to your institute that I am trying to apply to the NYU and so on. But that information is not required by the institute, but you have to give that information to the institute. And
Oh,
the same thing is with that. Like for example, when I'm buying something from Amazon, why that information is required by the bank? Bank should not care, because it is my money and I want to give it to Amazon and I want to buy some goods. Why bank should have any interest in that thing? So in this case, what happens, anonymity means whatever the data that is collected by the trusted intermediaries, we do not want that trusted intermediary to collect any data. And for the rest people, like for whatever the remaining nodes, we do not want them to find out any information. So that information they may not even previously also have. In the online banking also, suppose if I'm doing some transaction, other people are not aware that what transaction I have done. The only thing, only one extra person who has got that information is my bank. And what we want to do is we want to eliminate that party also. We even do not want bank or some academic institute or some for example the whatever the service providers are. In the case of if I'm going from a car from one location to the other location, I do not want that service provider to know that, have that information. And so this thing is also, we want this anonymity is not there because of this trusted intermediary, and that's why there is a good reason why we want to eliminate this trusted intermediary.
okay, sir.
The
Clear,
fourth,
sir. Thank you.
yes, the fourth point is fourth point is not possible to have ability to make non-reversible payments for non-reversible services. So this is again a very important thing. For example, suppose if you go to a particular shop and you buy a product, for example, suppose a product is something the shopkeeper says that you can check the product right now, but once you purchase that product, will not be able to get that product back. So suppose if you come back to us and ask us for a refund or return, we will not be able to give that facility. So there are going to be something called a non-reversible services and non-reversible payments. So for example, if you are buying an online course and after few days you think that that course is not good, and you say that whatever the videos in that course are, you have already watched those videos, and later on you say that I have not watched any videos and please give me the my money back. So that sort of things are possible. So there are some services that are non-reversible, and for non-reversible services, whatever the payments are, what we want is that payment should also be non-reversible. Now, the same thing is there in the physical money case. Like, for example, suppose if we go to a shopkeeper and if that is a non-reversible goods or non-reversible service, then that shopkeeper will not refund, will not going to give us the refund or the return or something. That same thing we want to have, that we used to have in a physical world, like beforehand. Now when we are using the online banking and others, what happens, this trusted intermediaries provides a non-reversible payments also in many of the cases. So suppose if you there is going to be a some sort of a transaction, and later on if you say that this transaction I have not done, or this transaction maybe the money is automatically deducted from my account or something, in that case there is going to be a reversal of that payment, and that reversal is something that we want to stop. So what we want to stop is, if there is a service that is non-reversible, the payment should also be non-reversible. Otherwise, some of the services will not be able to automate them and digitize them. So that thing is not there when we are using the online banking or some other stuff. And because of this trusted intermediary, so again, who does this sort of reverse payments? So this trusted intermediaries does the reverse payment. Otherwise, if there is only Keyur and Alice, and if I'm transferring some money to Alice's account, and then later on I ask Alice to send back the same money, Alice is going to deny that if it is a non-reversible service. So if there is a bank in between, then bank is going to again undo this transaction and transfer the money back to my account if I just claim something. So that thing is there when we are using the online banking, but that thing we want to eliminate for non-reversible services. And uh, that is primarily because of these trusted intermediaries who do that sort of reversal of payment, and that we want to avoid. So that is again one very good point to eliminate, why we are interested in eliminating these trusted intermediaries. Uh, One more thing that disadvantage of having this sort of trusted intermediaries are, the merchants acquire more information about their customers to avoid the dispute and the loss. So suppose if you are buying something from the Amazon, then Amazon is going to acquire lots of information from your side, like what is your name and address. And address is although required, but then there are some other information about the credit card details or the debit card details and phone numbers and these and that and many other details. So all those informations merchant acquire because they want to make sure that they can avoid the disputes and the loss later on. Now, as merchants are acquiring this extra information, uh, those sort of thing were not there. Like suppose if I'm going to my local store to buy some product, for example, to buy some grocery or something, then that grocery store owner is not going to ask me what is my mobile number or where exactly I'm living or other stuff. So all those information is not going to be acquired by that grocery store owner when I am doing that transaction physical in a real world physically. If we are doing that transaction in a digital world, that merchants are usually acquiring lots of extra information and to avoid the dispute and the loss. And what we want to do is we want to eliminate that sort of trusted intermediaries that acquire that extra information. For example, in the Amazon's case, Amazon is going to collect some goods from one location and deliver that products to my location. In between, that Amazon has acquired lots of information that was not there when I'm going to buy something from my local store and buy a product. So that extra information that is going to be collected by these merchants are something a big issue, and we want to eliminate that thing also. So that is also very good reasons like why we want to eliminate these trusted intermediaries. And the last point is a certain percentage of fraud is unavailable. So whenever we are doing that transaction in a physical world, like whenever we are giving the money to somebody to buy some products, there are slightly fewer chances of fraud. The same thing is not there when we are doing the online transaction. If we are banks and other people, whenever they are having number of customers, they also understand that there are going to be a some percentage of frauds, and that information that we usually see, like somebody's account got hacked or somebody's PIN number got hacked, and they'll be able to transfer a certain amount of money from one account to the other account and so on. So that sort of fraud is there in the online world. That was not there when we are having the actual transactions in physical world. So all those things are basically primarily attributed. All these limitations are primarily attributed to these trusted intermediaries. Because all these limitations are because of these trusted intermediaries, what we want to do is, can we eliminate these trusted intermediaries, and can we have a communication from two parties in a peer-to-peer way, the way we are used to have that sort of communication when we are exchanging that value in the real world. For example, I'm going to buy something from a grocery store or something, then that communication is going to be peer to peer. Like I'm going to buy some product and they'll ask me for some money and I'll get the good. So peer to peer communication was there, or peer to peer value exchange was there, and I want to have that same thing, and by without the trusted intermediary. So that was the reason why we want to eliminate the trusted intermediary. Do we have any of the weaknesses of this digital currencies while using the cash? The answer is no, and that we have discussed. And so Bitcoin solves a double spend problem without having the trusted intermediaries such as a financial institutions. So whatever the problem that so far we have discussed, that problem is going to be solved. Um, the first protocol or the first paper that publishes the solution of this double spend, like how do we facilitate the peer-to-peer exchange of a value. File transfer was already there, that is a torrent or something, but here what we want to do is peer-to-peer exchange of a value without that double spend. So without somebody is able to duplicate that thing and send it to 10 different people, we want to facilitate that peer-to-peer exchange of value. And for that solution, what somebody like the Satoshi Nakamoto, the name of that person or the group, he solved the problem, and he provided the solution, and that solution is primarily in this Bitcoin paper. So we are not going to discuss about that solution because then it will take something like 4 or 5 hours or something. But if you have any questions, you can ask now. So we are going to take some questions. So if you have any questions related to blockchain or Bitcoin or something, you can you're free to ask. And if I know the answer, I'll give you the answer. Or if you have some questions in this talk, you can also ask.
If anyone has any question or the doubt, they can ask it to sir. Sir, I think they don't have any
Okay, thank you.
problem. So thank you very
So
much, sir. So accept our invitation in the short notice period and give us the tremendous knowledge on the topic of the double spend problem that is very useful and meaningful to discuss in today's era. Thank you very much, sir.
thank you. Thanks a lot.
So participants, we are taking a lunch break from 1 to 2 and we will meet again at 2 o'clock. And we have one case study on the blockchain technology in the agriculture. That session is taken by Dr. Jinal Taylor ma'am. So we will meet again at 2 p.m. Thank you.